Everyone's heard of the Sten gun. Most people have seen one in a museum, behind glass, bolted to a display board with a little placard underneath explaining how the British churned out millions of them during the Second World War. Simple, cheap, ugly, effective. But almost nobody has heard the full story. The part that happened, not in factories, not in government arsenals, not in official military workshops with blueprints and inspectors and quality control checklists. The part that happened in basements, in barns, in the back rooms of bicycle repair shops and printing houses and farmhouses with blackout curtains nailed over the windows. The part where ordinary people, factory workers and farmers and school teachers and shopkeepers who had never built a gun in their lives picked up that same basic design and started making their own versions by hand, from scratch, with whatever they could find. And not just in one country. Across occupied Europe, from Norway to France, from Belgium to the Netherlands, from Poland to Czechoslovakia, resistance fighters were copying, adapting, improvising, and reinventing the Sten. Some versions were nearly identical to the original. Others were so heavily modified they barely resembled it anymore. A few were so crude they were genuinely dangerous to the person firing them, and some were actually better than the weapon they were modeled on. That last part is the one nobody talks about. Because the real story of the Sten gun isn't just about British manufacturing efficiency or wartime economics. It's about what happens when you strip a weapon down to its most essential components, hand the design to people with nothing to lose, and watch what they build with it. If you want to keep hearing stories like this one, the kind that go deeper than the standard history, that follow the weapon past the factory floor and into the hands of the people who actually used it, then make sure you hit subscribe right now before we go any further. We cover this kind of material regularly, and you don't want to miss what's coming next. But before we get to the basements, we need to understand why the Sten existed at all. Because the Sten wasn't born out of genius. It wasn't the result of years of careful engineering refinement or a revolutionary breakthrough in firearms design. The Sten was born out of desperation. And to understand that desperation, you have to go back to the summer of 1940, which was one of the worst moments in British military history. Dunkirk. The word still carries weight. In late May and early June of 1940, the British Expeditionary Force, along with hundreds of thousands of French and Belgian soldiers, was trapped on a beach in northern France, with the German Wehrmacht closing in on three sides and the English Channel behind them. The evacuation that followed was nothing short of miraculous in human terms, an armada of military ships and civilian boats pulling over 330,000 soldiers off the beaches in 9 days. But the equipment they left behind was catastrophic. The retreating troops abandoned thousands of artillery pieces, hundreds of tanks, tens of thousands of vehicles, and critically, hundreds of thousands of small arms. Rifles, machine guns, pistols, and the British Army's primary submachine gun at the time, the Thompson. The Thompson was a fine weapon, American-made, reliable, powerful. But it was expensive, heavy, and complicated to manufacture. Britain didn't have the industrial capacity to replace those losses quickly, and the United States, not yet in the war, couldn't supply them fast enough even through Lend-Lease. Britain was looking at the very real possibility of a German invasion with an army that barely had enough weapons to go around. Something had to be done, something cheap, something fast. The answer came from two men working out of the Royal Small Arms Factory at Enfield, Major Reginald Shepherd and Harold Turpin. Their names give the weapon one of its two letters. The S in Sten comes from Shepherd and Turpin. The EN comes from Enfield. Together they designed a weapon that was almost audaciously simple. Not simple in the careless sense, but simple in the disciplined engineering sense, where every unnecessary component has been stripped away, and what remains is exactly what the job requires, and nothing more. The Sten used blowback operation, which meant no complex gas systems, no locking mechanisms beyond the simplest possible arrangement, no parts that required precision machining to tight tolerances. The barrel was a tube, the receiver was a tube, the magazine well was a tube welded to the receiver at a 90-degree angle. The stock was a metal rod bent into shape. The whole thing looked, to be honest, like something a plumber had knocked together between jobs, and that was entirely the point. Because a weapon that looks like a plumber built it can in fact be built by a plumber, or a toolmaker, or a machinist in a small workshop with basic equipment. The tolerances were loose enough to allow production across dozens of different facilities simultaneously, without the parts becoming incompatible. And the result of all this deliberate simplicity was extraordinary in terms of sheer output. The British produced approximately 4 million Sten guns during the war, across multiple variants. The cost of each one started at roughly 10 shillings during peak production. Some estimates put the material cost even lower. This was a weapon that could be manufactured for roughly what it cost to take a family to the cinema. And that was before people started building their own. The first Stens, the Mach Y, appeared in 1941. They were quickly followed by the Mach II, which stripped away even more, eliminating the wooden forestock, simplifying the barrel jacket, reducing the number of components further. The Mach II became the most produced variant and the one most widely copied by resistance groups, partly because its simplicity made it easier to reverse engineer from photographs or from weapons dropped by Allied aircraft. And the British were dropping weapons to resistance fighters across occupied Europe in large quantities. The Special Operations Executive, the SOE, was doing exactly that, parachuting containers into fields in France and Belgium and the Netherlands and Yugoslavia and Greece and Scandinavia, containers full of weapons, ammunition, explosives, and equipment to support the growing underground movements fighting the occupation. The Sten was a natural choice for these drops. It was light, it broke down into a small package, and it used 9mm ammunition, which was the standard German pistol caliber, and therefore relatively easy for resistance groups to acquire through capture or theft. That practical detail matters more than people realize. A weapon is only as useful as the ammunition available to feed it. By chambering the Sten in 9mm, the British had given resistance fighters a weapon that could be resupplied from the enemy's own stockpiles. But the drops were never enough. There were never enough aircraft, never enough containers, never enough everything. The demand from resistance groups across occupied Europe consistently outstripped what the SOE could deliver, and so people started building their own. The decision to manufacture clandestine weapons wasn't taken lightly. Building a firearm in occupied territory wasn't like building one in a free country. If you were caught, you weren't fined or arrested. You were shot. Or you were sent to a concentration camp, which was frequently a slower version of the same outcome. The reprisals extended beyond the individual. The Germans routinely executed family members, neighbors, sometimes entire communities, in response to resistance activities. The decision to build a weapon in your basement, knowing what the consequences of discovery were, required a particular kind of courage that's difficult to fully comprehend from the comfortable remove of the present day. And yet people made that decision. Thousands of them across dozens of countries decided that the risk was worth taking, because the alternative, passivity, collaboration, waiting for liberation to come from outside while the occupation ground on indefinitely, was simply not acceptable to them. The practical challenge of building a clandestine Sten was significant, but not insurmountable, and the reason comes back to that fundamental design philosophy. The Sten's simplicity wasn't just a manufacturing advantage for official factories. It was an advantage for anyone with basic metalworking knowledge and access to the right materials. The main components required were steel tubing for the receiver and barrel, sheet metal for the trigger group housing, a few machined parts for the bolt and trigger mechanism, and a magazine, which could either be fabricated or, more commonly, salvaged from existing weapons. The tolerances required were achievable with basic machine shop equipment. A lathe helped enormously, but wasn't strictly necessary for every component. A drill press, hand files, and basic measuring tools could get the job done for most of the non-critical parts. The barrel was the most technically demanding component since it required both proper chamber dimensions and, ideally, rifling to impart spin to the bullet for accuracy. Some clandestine builders used plain smoothbore barrels, accepting a significant accuracy penalty for the sake of simplicity. Others found ways to cut basic rifling. A few obtained barrels from other sources, legitimate or otherwise. The materials themselves presented their own challenges. Steel tubing of the right dimensions wasn't always available, but creative substitutions were possible. Plumbing pipe of appropriate diameter could work for the receiver in a pinch. Automobile parts, industrial machinery components, agricultural equipment, all of these became sources of raw materials for underground workshops. The German occupation authorities were well aware that metalworking facilities could be used for clandestine arms manufacture, and they periodically inspected workshops and required businesses to account for their material inventories. Resistance organizers developed elaborate systems for acquiring and concealing materials, spreading purchases across multiple suppliers in quantities small enough not to attract attention, maintaining false inventory records, and distributing the actual manufacturing across multiple locations so that no single raid could shut down the entire operation. The workshop locations themselves were chosen with care. Basements were popular because they offered noise insulation, limited the number of entry and exit points that needed to be monitored, and provided a degree of concealment for the telltale sounds and smells of metalworking. But basements were also potential traps if the building was surrounded. Some groups preferred outbuildings on farms, where the normal sounds and activities of agricultural work provided cover. Others used existing workshops, building the clandestine activity into the margins of legitimate business operations, with warning systems in place to allow concealment if authorities arrived. The social infrastructure required to support these operations was as sophisticated as the technical one. Networks of trust, developed over months or years, connected material suppliers, fabricators, finishers, and distributors. The failure of any link in that chain could compromise the entire network. Security was maintained through compartmentalization, with most participants knowing only their own role and the identities of the one or two people directly above and below them in the organizational structure. This wasn't paranoia. It was rational risk management in an environment where infiltration by German intelligence and their local collaborators was a constant threat. Denmark is one of the places where the clandestine Sten story is perhaps best documented, and it offers a remarkable window into how these operations actually functioned. Denmark had a somewhat unusual experience of occupation compared to many other European countries. Initially, the German occupation was relatively light, with the Danish government continuing to function and the occupation authorities maintaining a facade of normalcy that served German propaganda purposes. But as the war progressed and the resistance intensified, the situation deteriorated sharply. After August 1943, when the German authorities imposed martial law and the Danish government ceased to cooperate, the resistance became more active and the repression more severe. Danish resistance groups had been receiving SOE supplies since 1941, but the quantities were never sufficient, and the logistical challenges of parachute drops in a relatively flat, densely populated country were considerable. Danish resistance organizers began exploring domestic production options, and the Sten's design, already familiar from dropped examples and from photographs and technical information provided by the SOE, became the basis for a significant clandestine manufacturing effort. Danish workshops produced Sten copies and variants throughout the latter part of the occupation. Some were remarkably faithful to the original design. Others incorporated local adaptations based on material availability or the particular skills and equipment available to the builder. The quality varied considerably, as you would expect from a distributed manufacturing operation with no centralized quality control, but the weapons generally functioned well enough to serve their intended purpose. What makes the Danish case particularly interesting is the documentation that survived. Because Denmark was liberated relatively intact compared to countries like Poland or Yugoslavia, where the destruction was far more comprehensive, a significant number of clandestinely manufactured weapons survived the war and ended up in museums and archives. Danish historians have been able to examine these weapons in detail, and what they've found is fascinating. The variations from workshop to workshop are significant. Some builders clearly had access to good machine tools and used them. Others worked with more primitive equipment and compensated with clever design workarounds. A few show evidence of repairs and modifications made during use, testimony to the weapon's actual deployment in the field. And some show details that aren't present in any official British version, local adaptations developed by builders who identified ways to improve on the original design, whether through better ergonomics, simplified manufacturing of specific components, or solutions to reliability problems that the original design was known to have. Because the Sten had problems, real ones, the weapon's reputation for reliability was decidedly mixed, and the issues were well known to everyone who used it. The most notorious was the magazine. The Sten used a side-feeding double-stack, single-feed magazine that was genuinely temperamental. The lips of the magazine, the two small metal tabs that controlled the feeding of rounds into the chamber, were critically sensitive to damage. A magazine that had been dropped, sat on, or simply handled roughly could develop feeding malfunctions that rendered the weapon useless. The magazine lips were also prone to wearing and deforming over time with normal use, requiring careful maintenance. Soldiers and resistance fighters learned to handle Sten magazines with considerably more care than the robust appearance of the weapon might suggest was necessary. The feeding issues weren't limited to damaged magazines. The geometry of the double-stack single-feed arrangement created inherent feeding angle challenges, and even undamaged magazines could cause jams under certain conditions, particularly if the weapon was tilted to one side during firing, which could cause the stack of rounds to shift and misalign with the feed lips. Experienced Sten users learned to support the magazine from below when firing, rather than holding the magazine housing itself as a pistol grip, a temptation that the design's layout made natural, but which introduced exactly the kind of lateral pressure that caused feeding problems. The trigger mechanism was another area of concern. Early Sten variants had a safety arrangement that was simple to the point of being potentially dangerous. The basic safety worked by rotating the bolt handle into a notch in the receiver, physically preventing the bolt from moving. But this arrangement was vulnerable to being dislodged by a sharp impact, and there were documented cases of Stens discharging when dropped or struck against a hard surface. The phenomenon of the Sten going off unintentionally was so well known that it became part of the weapon's folklore, and instructions for its use regularly emphasized careful handling and the importance of keeping the chamber empty until actually needed for use. Various modifications were developed to address this. Some official variants incorporated improved safety arrangements. Some users improvised their own solutions, wedging pieces of rubber or wood into the bolt handle notch to make accidental discharge less likely, adding safety devices from other weapons, or simply developing handling procedures that minimized the risk. Clandestine builders, working without the institutional conservatism that often prevented official designs from adopting field improvements, were frequently more willing to incorporate these modifications into their weapons from the start. The barrel retention system on early Stens was another source of frustration. The barrel was held in place by a simple collar arrangement that worked adequately in ideal conditions, but could loosen with use, particularly if the weapon was fired extensively or if the parts were worn. A loosening barrel could affect accuracy, and in extreme cases create a safety hazard. Again, this was a problem that experienced users found ways to manage and that clandestine builders sometimes improved upon. The barrel shroud and the method of its attachment varied considerably between clandestine versions, with some builders developing more positive retention systems than the original provided. The accuracy of the Sten was, to put it charitably, adequate for its intended purpose and nothing more. The weapon was designed as a close-range tool for the defense of positions, ambushes, and close-quarters fighting. At ranges beyond about 50 meters, the combination of the relatively short barrel, the blowback operation, and the open bolt design made consistent accuracy difficult. The open bolt design meant that when the trigger was pressed, the bolt was traveling forward and chambering around at the moment of firing, which created a small but consistent disruption in the weapon's aim point. This wasn't unique to the Sten and was common to most submachine guns of the era, but it was a genuine limitation for anyone expecting precision fire at extended ranges. Resistance fighters learned to use their Stens accordingly, planning ambushes at ranges where the weapon's limitations didn't matter, and avoiding engagements where sustained accurate fire at distance was required. France produced some of the most sophisticated clandestine weapon manufacturing operations in occupied Europe, and the French experience with the Sten illustrates both the possibilities and the limitations of underground production. The French resistance, or more accurately, the collection of often competing and suspicious French resistance organizations, had a complex and difficult relationship with both the British authorities and with each other. The SOE maintained extensive networks in France throughout the occupation, but the drops of weapons and supplies were subject to constant disruption by German countermeasures and by the logistical challenges of operating over such a large and geographically varied country. French clandestine workshops produced a significant number of Sten copies, but they also produced original designs, weapons that borrowed the Sten's basic operating principle while incorporating French adaptations. Some of these were chambered for the 7.65mm cartridge, which was more readily available in France than the 9mm Sten cartridge, reflecting the practical prioritization of ammunition supply over strict design conformity. Others incorporated stocks of different configurations, better suited to users trained on French military weapons or simply more comfortable for people who had never had formal weapons training at all. The question of who was doing the building is important and often overlooked. When we talk about resistance fighters manufacturing weapons, it's easy to create a romantic image that doesn't quite match the reality. The people who actually fabricated the weapons were typically not the same people who used them in the field. They were skilled workers, machinists, tool and die makers, mechanics, gunsmiths, engineers, people whose professional knowledge and access to equipment made them valuable contributors to the underground in a very specific way. These individuals often had no direct involvement in operations. They built the weapons, handed them off through the network, and went back to their daily lives, carrying the weight of what they'd done and what would happen to them if it was discovered. The operational fighters who received those weapons frequently had little idea of how they had been made, or by whom. The compartmentalization that protected the network meant that each participant knew only what they needed to know. This division between the makers and the users has contributed to the relative invisibility of the manufacturing side of resistance history. The operational stories, the ambushes, the assassinations, the sabotage generated the dramatic narratives that filled post-war memoirs and later became films and novels. The quiet, skilled, terrifying work of the basement fabricators left fewer traces in the historical record, partly because security concerns meant they kept no records themselves. Poland's experience deserves particular attention because it represents perhaps the most extreme case of clandestine weapons manufacturing during the war, driven by the most extreme circumstances. Poland under German occupation was subject to a level of systematic brutality that was qualitatively different from what most of Western Europe experienced. The German occupation of Poland was explicitly designed as a program of elimination, the extermination of the Polish intelligentsia, the eventual enslaving of the surviving population, and the transformation of the country into German colonial territory. Under these conditions, armed resistance was not an option, it was a necessity, and the Polish Home Army, the Armia Krajowa, developed into one of the largest and most sophisticated resistance organizations in occupied Europe, with a military structure, intelligence networks, and an underground manufacturing capability that was remarkable by any standard. The AK's clandestine arms production went far beyond simple copies of dropped weapons. Polish engineers and machinists developed entirely original designs alongside their production of Sten copies and other foreign weapons. The most famous of these was the Błyskawica, which means lightning in Polish, a submachine gun designed specifically for clandestine manufacture that appeared in 1943. The Błyskawica was chambered in 9mm and used the same basic operating principle as the Sten and the German MP40, but it incorporated a number of design improvements that reflected both the lessons of actual combat experience and the particular manufacturing capabilities available in underground Warsaw. The Błyskawica's design was optimized for production in workshops that might have only limited machine tool capability, with tolerances and joining methods chosen to be achievable without specialized equipment. It used a folding stock that made it easier to conceal and transport. Its trigger mechanism was more sophisticated than the Sten's basic arrangement, incorporating a selector that allowed both semi-automatic and automatic fire, which the basic Sten did not provide. It was, by almost any measure, a more capable weapon than the Sten it partly drew inspiration from, designed by people who had thought carefully about what the Sten's limitations were and how they could be addressed. The Błyskawica is a remarkable artifact, but it's important to understand what it represents in the broader story. It's the endpoint of a process that began with copying, moved through adaptation, and arrived at original creation. The Polish engineers who designed it had started, like resistance groups everywhere, by building what the British had already designed. But the process of building copies, of examining the design in detail, understanding why each component was the way it was, identifying what it did well and what it did poorly, gave them the knowledge and confidence to go beyond copying and create something new. The Netherlands offers another fascinating chapter in this story, one with its own particular characteristics, shaped by Dutch geography, industry, and the specific nature of the German occupation there. The Dutch resistance was slow to develop compared to resistance movements in countries that had experienced invasion rather than surrender, but by 1943, and particularly in 1944, it had become a significant force with extensive networks for intelligence, sabotage, and evasion. Dutch clandestine weapons manufacturing benefited from the country's industrial base. The Netherlands had a sophisticated engineering and metalworking industry, and even under occupation, the skills and equipment required for precision metalwork were available in various forms. Dutch Sten copies and adaptations were, on the whole, among the better-made examples of clandestine production, reflecting the higher baseline of industrial capability available to their makers. The Dutch also benefited, at least initially, from relatively good communications with London through the SOE's N section. The later stages of this relationship became one of the great intelligence disasters of the war, when German counterintelligence succeeded in completely penetrating the SOE network in the Netherlands in what became known as the Englandspiel, or England game, resulting in the capture and execution of a large number of SOE agents and the interception of weapons drops for a considerable period. But even during this compromised period, Dutch resistance groups continued to acquire and manufacture weapons through channels that operated independently of the SOE networks. Belgium's situation was shaped by the country's particular geography and industrial character. A small, densely populated, highly industrialized country, with significant experience of occupation from the previous war, Belgium developed a resistance that was sophisticated from relatively early in the occupation. Belgian clandestine Sten production was distributed across the country's industrial heartland in ways that made it particularly difficult for the German authorities to suppress. The concentration of metalworking expertise in Belgium's industrial regions meant that the pool of people capable of contributing to clandestine manufacturing was large and widely distributed, and the existing industrial networks provided cover for the movement of materials and components. Belgian Sten copies show a characteristic attention to finish and detail that reflects the culture of precision manufacturing in the country's engineering industries. Some examples are difficult to distinguish from official British production without close examination, not because the Belgians were copying carelessly, but because they were copying with the same care and precision that their industrial tradition demanded. Norway's experience adds a different dimension. The Norwegian resistance operated in a country where geography provided both advantages and challenges. The extensive Norwegian coastline and the network of fjords made the country difficult to patrol comprehensively, providing opportunities for seaborne resupply that didn't exist in more landlocked occupied territories. But Norway's dispersed population and its climate created their own difficulties for clandestine operations, and the German occupation authorities were well aware of Norway's strategic importance, maintaining a substantial garrison and intelligence presence throughout the country. Norwegian clandestine weapons manufacturing included both Sten copies and original designs, some adapted to the particular needs of resistance operations in challenging terrain. The Norwegian resistance placed a high premium on mobility and concealment, and some of their clandestinely manufactured weapons reflect this, with designs optimized for easy disassembly, small package size, or concealment in everyday objects. The Norwegian Sten variants show a characteristic adaptation to operating in cold weather, with modifications to ensure reliable function in the temperature extremes that resistance fighters operating in the field would encounter during Norwegian winters. It's worth taking a moment to consider what the weapons actually looked like when they came out of these basement workshops, because the range of quality and appearance tells its own story about the conditions of production. At one end of the spectrum were weapons that, to a casual observer, might have been indistinguishable from factory production. These came from workshops with good equipment, skilled operators, and time to do the work properly. The receiver tubes were cut square and true. The welds were clean. The machined components fit together with the right clearances. The finish might be rough or improvised, blued with improvised solutions, or simply left as bare metal with a coat of oil. But the fundamental geometry was right, and the weapon functioned reliably. At the other end were weapons that showed the compromises forced by inadequate tools, limited time, and inferior materials, welds that were strong but irregular, machining that was approximate rather than precise, parts assembled with modifications or shims to make them fit when the original dimensions were slightly off. These weapons often functioned adequately, at least initially, but their reliability declined more quickly with use than better-made examples, and they were more prone to the kinds of malfunctions that could be catastrophic in the situations where they were used. The middle ground, representing the majority of surviving examples, shows weapons that were clearly made with care and skill within the constraints available, with individual components showing varying levels of finish that reflect the different operations and equipment used to produce them, assembled into complete weapons that worked well enough to justify the risk of making them. The finishing of clandestinely manufactured weapons is an interesting detail in itself. Official Sten production used established metal finishing methods including bluing or phosphating, which provided corrosion protection and reduced reflectivity. Clandestine manufacturers needed to solve the same problems with less access to the chemicals and equipment used for industrial finishing. Improvised bluing solutions made from household chemicals were common, producing a functional if uneven finish. Some weapons were simply oiled, which provided adequate protection for the short operational lifespans most of these weapons were intended for. A few examples show creative use of paint, tapes, or wrappings that addressed both the finish and the identification problem, since a weapon with distinctive markings or an unusual color scheme was harder to identify as a clandestinely manufactured firearm if it was found during a search. The magazines deserve special discussion because they were often the most challenging component to manufacture and the most critical to reliable operation. Sten magazines required relatively precise construction of the feed lips to function correctly, and achieving the right dimensions without proper gauging equipment was difficult. Many clandestine production operations found it easier to focus on manufacturing receivers, bolts, and trigger groups while using magazines from existing Stens, either dropped by the SOE or captured from German forces. The Germans actually used captured Sten guns extensively, finding them entirely practical for their own purposes, which meant that German-held magazines were sometimes accessible to resistance groups through theft or capture. Other groups developed their own magazine manufacture, accepting the reliability variability that came with inconsistent feed lip dimensions and compensating through careful selection and testing of manufactured magazines before issuing them. Some clandestine versions used different magazine designs entirely, adapting to feed from magazines of other weapons that were more available or easier to manufacture in the local context. There's a psychological dimension to this story that's easy to miss if you focus too closely on the technical details. The act of manufacturing a weapon in occupied territory was itself a form of resistance, distinct from and preceding its use in operations. The person who built a Sten in their basement, who spent hours filing and machining and welding in secret, who hid the components under floorboards or in concealed spaces, who lived every day with the knowledge that discovery meant death, was doing something that mattered beyond the immediate military utility of the object they were creating. They were asserting agency. They were refusing to be passive. They were demonstrating, to themselves as much as to anyone else, that the occupation could not simply erase them, that ordinary people retained the capacity to act, to create, to resist. The weapon itself was a symbol of that assertion, and its manufacture was an act of defiance that carried meaning regardless of whether it was ever fired. This psychological dimension helps explain some of the choices that resistance weapon makers made that don't make obvious sense from a purely tactical or technical perspective. Groups that had access to adequate quantities of SOE-supplied weapons still maintained domestic manufacture, partly because the supply chain of drops was unreliable and building a buffer stock made sense, but also because the capability to manufacture weapons was itself a form of power and independence that no one wanted to surrender entirely to an external supplier's decisions about priorities and allocations. The ability to say we can make our own was important beyond the weapons it produced. The relationship between clandestine manufacturers and the official resistance command structures was sometimes tense. Centralized resistance organizations generally wanted to maintain control over weapons manufacture and distribution for the same reasons any military organization wants to control its own logistics. Unauthorized manufacturing created supply lines that weren't under central control, produced weapons of variable quality that reflected on the organization's operational reliability, and created security vulnerabilities that weren't covered by the organization's existing security protocols. Independent workshops that operated outside the official structure were theoretically more secure in some ways, since their compromise didn't automatically compromise the central network, but they were also harder to support and potentially harder to discipline if their output didn't meet operational needs. Different resistance organizations handled this tension differently. The Polish Home Army, with its quasi-military structure and substantial organizational capacity, was able to bring a significant proportion of clandestine manufacture under some degree of central coordination, while still benefiting from the distributed, compartmentalized nature of the production network. French resistance groups, more fragmented and politically diverse, had less ability to impose centralized control and generally operated with a more anarchic distribution of manufacturing capability. Both approaches had advantages and disadvantages, and both produced weapons that played important roles in resistance operations. The SOE's own perspective on clandestine manufacturing by resistance groups evolved over the course of the war. Initially, the organization's focus was on supplying weapons from Britain and discouraged independent manufacture, partly for security reasons and partly because of concerns about weapon quality and compatibility with supplies being provided through official channels. As the war progressed and the scale of resistance activity expanded beyond what supply drops could support, the SOE's position shifted toward active encouragement and support of local manufacture. Technical instructions were developed and distributed, covering not just the Sten, but other weapons and equipment that could be manufactured locally. Some of these instructions were prepared specifically for distribution to resistance groups, simplifying official designs to make them more accessible to builders without specialized engineering backgrounds and providing guidance on materials and tool substitutions. The evolution of SOE's technical support program reflects a sophisticated understanding of what resistance groups actually needed. It wasn't enough to provide weapons and hope for the best. Effective resistance required sustainable capability, and sustainable capability meant being able to maintain and replace weapons independently of the supply chain from Britain. The investment in local manufacturing capacity was an investment in the long-term effectiveness of resistance movements, even if it created complications in the short term. The end of the war brought its own strange epilogue to the story of clandestine Sten manufacture. As liberation came to various parts of occupied Europe, the weapons that had been made in basements and barns and back rooms emerged into daylight for the first time. Some were used in the final fighting, the street battles and partisan operations of the liberation period. Others were surrendered to Allied authorities or turned over to the new national armies being reconstituted, and some simply disappeared, tucked away by their owners as insurance or as relics, stored in attics and buried in gardens and hidden behind walls, not found in some cases for decades. The discovery of these weapons long after the war's end has provided much of the physical evidence that historians and museum curators have used to study the manufacturing techniques and design variations of the clandestine production period. Each weapon is a time capsule, encoding in its construction details about the tools available, the skills of the maker, the materials accessible, and the decisions made under conditions of extreme pressure and danger. The post-war period also saw some of these improvised manufacturing techniques continue, though in very different contexts. In various conflicts and insurgencies around the world in the post-war decades, the basic concept of the Sten, a simple blowback submachine gun that could be manufactured from basic materials with limited equipment, proved as relevant as it had been in occupied Europe. Copies and near copies of the Sten turned up in conflicts in the Middle East, in Asia, in Africa, made in circumstances that rhymed in disturbing ways with the basement workshops of wartime Europe. The Sten's design proved so fundamentally sound in its simplicity that it became, in a sense, a template for clandestine weapons manufacture in general, demonstrating that the intersection of accessible design, available materials, and human ingenuity could produce functional weapons in almost any circumstance. There's a technical legacy to the story as well. The clandestine manufacturers of occupied Europe contributed, in their way, to the broader development of weapons design, by demonstrating what was truly essential and what was optional in the Sten's design. Their modifications, adaptations, and improvements, driven by practical necessity rather than theoretical consideration, produced a body of evidence about what worked and what didn't that professional weapons designers in the post-war period could draw on. Some of the improvements developed in basement workshops ended up influencing the design of subsequent submachine guns, not through direct documentation of the clandestine work, but through the broader diffusion of ideas that occurs when a large number of people engage seriously with the same engineering problem. The lesson that the Sten's magazine was its critical weakness, understood by every resistance fighter who ever had a jam in a bad moment, informed subsequent submachine gun designs that prioritized magazine reliability in ways the Sten never had. The broader lesson of the experimental Sten copies made in occupied Europe is not primarily a technical one, though the technical dimension is real and interesting. The broader lesson is about the nature of resistance and the remarkable capacity of ordinary people to do extraordinary things when circumstances demand it. The machinist who made a Sten in occupied Belgium, the engineer who designed the Błyskawica in underground Warsaw, the farmhand who learned enough metalworking to produce a functional firearm in a Norwegian barn. These people were not soldiers by training or inclination. They were ordinary people who found themselves in extraordinary circumstances and responded with the resources available to them, which in many cases were primarily their own intelligence, skill, and determination. The Sten was the ideal weapon for this kind of response precisely because its design acknowledged the reality of limited resources. It was a weapon that said, in its design language, "We know you don't have much, here's what can be done with a little." That acknowledgement, built into the metal and the geometry of the thing, gave resistance fighters across Europe something they could actually work with. Not a complicated, demanding weapon that required factory production and trained maintenance personnel, but a simple, adaptable tool that could be understood, reproduced, and improved by anyone with basic skills and sufficient motivation. There's something almost philosophical in the Sten's design, if you look at it the right way. The deliberate simplicity of the Shepard and Turpin design was not just an engineering choice or a manufacturing expedient. It was an implicit statement about who should be able to defend themselves and under what circumstances. By stripping the weapon to its essentials, the designers had created something democratically available in a way that more sophisticated weapons were not. You didn't need a factory. You didn't need a government. You didn't need an army. You needed a workshop, some materials, some skills, and the determination to use them. In the specific circumstances of occupied Europe, where the state had been replaced by an occupying power that was systematically working to deny the population any means of resistance, that democratization of the means of self-defense was not an abstraction. It was the difference between survival and extinction for many of the people who built and used these weapons. The historical significance of the clandestine Sten program extends beyond its immediate military contribution, which was real but not decisive in the grand strategic sense. What it contributed was something harder to measure and more durable. It demonstrated that occupation, however brutal and comprehensive, could not completely suppress the human capacity for resistance. That in basements and barns across a continent, under the heel of the most powerful military force the world had yet seen, ordinary people were quietly, dangerously, defiantly building the tools of their own liberation. That's a fact that deserves to be remembered not just as a historical curiosity, but as testimony to something fundamental about human nature. The Sten was ugly and unreliable and cheap. The copies made in occupied Europe were often uglier, sometimes less reliable, and cheaper still. But they worked, and the people who made them and used them changed history in ways that no amount of industrial military production could have achieved on its own. The German occupation authorities were certainly aware that weapons were being manufactured clandestinely. The raids on workshops, the interrogations, the executions of people found with manufacturing equipment or materials were evidence of that awareness. But despite the terror they deployed, they never succeeded in suppressing the underground manufacturing networks entirely. For every workshop they shut down, others opened. For every fabricator they arrested, others stepped forward to take their place. The network was too distributed, too resilient, too deeply embedded in the fabric of daily life to be eradicated by even the most comprehensive policing. This resilience was itself a form of weapon, not a physical one but a moral one, demonstrating to the occupiers and to the occupied population alike that resistance could not be eliminated, only contained at enormous cost and never permanently. What the Sten's clandestine legacy ultimately teaches us is something that military historians and weapons designers have known for a long time, but that the broader public rarely thinks about. The most important characteristic of a weapon is not its accuracy, its rate of fire, its effective range, or its reliability under adverse conditions. The most important characteristic is whether it can be gotten into the hands of the people who need it. All the sophisticated engineering in the world is useless if the weapon can't be produced in sufficient quantities, supplied through reliable channels, and maintained by the people using it. The Sten, in all its ugly simplicity, solved that problem better than almost any weapon before or since. And the clandestine manufacturers of occupied Europe took that solution and extended it to its logical conclusion, demonstrating that with the right design, a weapon could be not just mass-produced by factories, but manufactured by individuals, scattered across a country, in ways that made suppression effectively impossible. That's the real story of the experimental Sten copies, made in basements across occupied Europe, not just a story about guns, a story about ingenuity and courage and the remarkable human capacity to resist, to adapt, to create, even in the darkest possible circumstances. A story about what happens when you give people a problem they can solve, and the tools to solve it with, even when those tools are incomplete and the circumstances are terrifying. A story that starts with a couple of engineers at Enfield who decided that simple was better than complicated, and ends with an ordinary person in a basement somewhere in France or Belgium or Poland or Norway, filing a piece of metal by the light of a single bulb, knowing that what they were making could get them killed, making it anyway. The weapons they built weren't beautiful. Most of them weren't even particularly good, but they were real, and they were there, and they worked when they were needed. And that, in the end, was exactly what the Sten was designed to